Next, again, very important property, basic strength of hydrides of what? 15th group. Okay, that is, we can call it what? EH3. Okay, as electronic configuration we have already checked is what? NS2 NP3. Okay, that is one lone pair is present and three bond pair is present. Therefore, EH3 can be simply represented as what? EH3 and one lone pair. That is, in case of hydrides, there is a lone pair and three hydrogen atom, which we have already discussed in earlier video. Getting? Now, due to presence of lone pair on central atom, okay, they can donate what? Lone pair. They can donate the lone pair. So all hydrides act as what? One which can donate lone pair are simply called what? Lewis bases. Means all the compounds act as Lewis bases. Now, if we have to see or observe the strength of these bases, so strength of Lewis base depends on what? Depends on how easily, okay, compound can donate lone pair. Compound can donate what? Lone pair. Okay, now how easy compound can donate lone pair? Again depends on electron density around central atom. That is what? As greater the electron density, there will be more repulsion. That is, as greater the electron density, more will be repulsion. Okay, between electron pairs. Like if we talk about NH3, this is N, this is H3. Now earlier we have checked that due to comparatively strong electronegativity of nitrogen, the electron density around nitrogen becomes very, very high. Therefore, it can easily release its lone pair. Isn't it? So, we can write here in NH3 and have a very high electron density. Okay, now due to what? Due to number A, what? Polarity, and number 2 what? Small size of N. Small size of what? Nitrogen atom. Okay, hence NH3 can easily donate lone pair. I am writing in short, okay? Easily donate lone pair, okay? But as size of central atom increases, okay, central atom increases what? Down the group of other hydrides. Okay, volume increases other hydrides, volume increases. Okay, hence lone pair can be easily accommodated. Easily accommodated. Okay. Also, what? Electron pair repulsion decreases. So two factor work here. Electron pair repulsion decreases. And if what? Electron pair repulsion will decrease, then the tendency to donate lone pair will decrease. So tendency to donate what? Lone pair decreases, and therefore the basic nature also decreases. That is, we can say the SbH3 the last hydride what? BiH3 is least basic in nature, while the next one SbH3 is more basic, and AsH3 is again more basic. The pH3 is more basic, but the highest basic will be what? Ammonia. Therefore, ammonia and their derivatives are considered as basic in nature. We have checked it in nitrogenous compound. Okay, again, why do NH3 is more basic as compared to other hydride? This is due to very important two factor. What? A smaller size of N, and second one, polarity of N. Thus, the electron density around nitrogen atom in ammonia is high. Therefore, it can donate its lone pair more easily. So, student, along with I am also giving you notes in the writing. Although I am also giving the pic, but the handwritten notes are also there, so that you can prepare your own notes.